Alright guys, how's it going? So today I'm going to be showing off a circuit I made in digital that renders Mandelbrot, and I had a circuit like this that I showed off before, but it didn't have zooming and panning. So this one allows for zooming and panning, but it only has a fixed hardware, 15 hardware iterations. So as I zoom in, you're going to see that, like, even if you zoom in more, you're not going to get any more detail, and that's because I'm only doing 15 iterations. If I bump the iterations up to 32 or 64, you'll get more view. So I want to show you that by, like, zooming in on the Valley of the Seahorses and showing you how that works. So, with the simulation, I can hear the controls up here. Panning uses the arrows on your keyboard. Pan amount is to increment is X, to decrement is Z, and you'll see the zoom level here increase and decrease as you do that. The zoom, pan amount, you'll see this increase and decrease here, the pixels per pan. The zoom is L and K to go up and down respectively, and then you'll see the zoom level change. If you start zooming out, you'll see negatives here. If you start zooming in, that'll stay as a 1, and then you'll see the zoom level increase. So it's like 2 to the whatever power. So that's how I tell you if you're zooming in or out. Toggle frame or draw frame is just N. Toggle clock is space. That's just like toggle simulation is what that means. And then reset to default is R. So it's already at its default. So now what we're gonna do is we want to get this this Valley of the Seahorses down here, because right now the way the zoom works is it zooms in on the bottom left corner. I want to change that so it zooms in on the middle, which I have to just add some more logic in, but I just wanted to record this video first because it's like a progress report update, because what's coming next is pipelining on this. So you'll see the arrows, you can see the colors up here light up when I was pressing the buttons that moved it. So I press the up arrow, it's moving my frame up, which is moving the Mandelbrot down, if that makes sense. So press up a few times. And that's how I want to increment how much I pan every time I press it. Well, I could just press X here, and you'll see that now when I pan a few times, I don't have to press as much and it moves even more. Now you can also pan around while it's drawing the current frame, for instance like this. But you see it screws up the drawing and you have to redraw for the rest of the frame. So we're moving it, we're trying to get that Valley of the Seahorses right over to the bottom left corner. Okay, so now we're going to increment our zoom level. So to do that, we're going to press L. And now you see our zoom level went to 2. We press N. Okay, cool. We zoomed in. We're at 2x zoom now. So we'll increment how much pixels we pan by. And we'll move to the right a bit and up a bit. And redraw our frame. We'll move to the right a bit more. And we'll move down a little bit, or up a little bit, sorry. There we go. And we'll move to the right just a little bit more and redraw. Okay, and now what we're going to do is we're going to increment our zoom level again. So we're going to press L, it'll go to 4x, we'll press N, we'll redraw our frame. Now you'll see we're at the Valley of the Seahorses, and we don't really have much, we can't really see what's going on down here very well. Like, this really just comes all the way down, right? Like, but we can't see that because we only have a fixed hardware number of 15 hardware iterations. So since that's fixed, I can't really get like a better view here, even if I zoom in or zoom out. But we can pan around some more. So if I increment how much I pan around and we move up a bit and move to the right. You can look at some of the other parts of the set here. Let's look at one of these long shoots coming off. I'll move it to the right a bit. Oh, a little too far. We're going 16 pixels per pan, that's in hex. Okay, we'll go over a little bit more. Cool. Alright, so now we'll press L to zoom in. Oh, you can see it start doing that, and there we go. So now we're at 16x zoom. And let's follow that little tendril coming off. Alright, I'll zoom in just a little bit, or move up, pan around just a little bit more. And now let's zoom in again. Go to 32x zoom, there we go, draw a new frame. And you can see, like, we can, just because we can zoom in more, doesn't mean we're going to get anything more out of this. Oops, just lost it. Yeah, so it's quite easy to lose where you are here, so we can just press R and then draw a new frame. I guess I didn't press R. I guess it didn't register. Give it one more. Press R, there we go, and now we press N, and now we're back. So you can always get back to the beginning there. Let's zoom in, let's go to like one of the mini brots at the end here. Let's tell it to move 8 pixels per pan. Get that down here. And now we'll zoom in by pressing L. Let's try to zoom in on this guy right here. So we'll move down a bit, we'll move over a bit, and draw the frame. Oops, I moved in the wrong direction. I moved to the right, not to the left. If I want to see... Oops, I don't know what just happened here. Oh, I pressed the spacebar by accident. Shoot. And that's what happens if you press the spacebar. So I guess we'll just restart. Reset, draw a new frame. Alright, don't press the spacebar. I don't know, we don't want to change our zoom level yet. We want to go do that, we just want to increment our pan. We want to move our camera up. Alright, now we'll press N. Oops, nope, or L, sorry. We want to go to 2x zoom. Let's move that down. Perfect. Maybe we'll go to the right a bit more. Oops. Alright, a bit much. There we go. Oops. Just, gotta finish drawing the frame. It's kind of lagging out. There we go. Alright. Perfect. Now we'll zoom in again. Draw a frame. Oh, we zoomed in 4. We went from 2 to 8, so we doubled twice. So we have to move the camera up. And you can see that we're not going to get a better looking mini brot there. It's always going to look that crappy because we only have 15 iterations. It's fixed at 15. So if I wanted a better looking brot there at the end, zooming in is not going to help. So I have a bunch of zoom levels and not enough iterations to see all that zoom if that makes sense. Oops. We really just lose it. Yeah. Zoom out a few times, figure out where we are. Oh, there it is. Yeah, so you can explore the set a little bit with this, but obviously it's not as good as like a real software, like a software thing running on a GPU, because this is software emulating hardware that's then rendering it. So if you wanted it to actually be good, you would have to build the hardware in real life. The thing that's going to come next after this is well, more iterations, and also it's going to be pipelined, because right now it's kind of just doing all the iterations per pixel, and then it's generating a pixel value, and then the next one comes in and does that. So that's why the clock is so slow. But if I could break this up into stages, send the pixel value with like if it blew up or not, and then the value that it should be colored, send it through the pipeline, and then when it gets to the end, then that's what it does. And then you can, however many stages you have, each one is a pipeline stage. That's would be cool. I don't know how much that would actually improve what it does in this software or not. But yeah, if you guys want to try this out, I'll have a download link in the video, also, or in the video description. Also, the controls for it is really simple. Like, you just press space to start and stop the clock in the simulation. You have to click enable off the default, and then it's just going to draw a black screen like that. So if you want it to get it to work, you press R. As you see, I press R and that button's pressing. Then if I press N, it does that, and then it draws a new frame. So R will reset it so it doesn't just draw black. And then from there you have full control over zooming and panning just based off of these controls here. And this is just some nice indicators here. So like when you increment pixels per pan, you see like a green light, and when you decrement you see a red light. And when you increment the zoom level, you'll see green when you're pressing the button, and when you decrement it, you'll see that. So the way it works is it just divides the clock down by 1,000. So if you enter a 5,000 hertz clock, it's gonna, like, every time you press the button, it's just gonna pull it 5 times a second, basically. So this way it doesn't increment or decrement too much when you hold the button down, and it prevents you from, yeah. So you can go down all the way to negative 4,096, right? It's not gonna look like shit, yeah. But what was that? Yeah, 512. So that's zooming out, but then zooming in is this. So if we go back to that, yeah, let's see how far zooming out you can go. You can see it get drawn as I move. That's cool. Yeah, it's not worth zooming out. Alright, yeah, I think that's enough for this video. I'll leave everything in the comment or in the description for the download for this, and yeah, all you have to do to run it is just launch zoombrat.dig in digital, and it'll work. Yeah, so thanks for watching, and I'll see you guys next time. Okay, and for those of you who are still around, I guess I'll show some stuff that changed. So if we open up this circuit, so the way it works to pan and zoom, well, okay, wait, no, you can't do this. You have to look at the circuit first. So this has cleaned up a lot of what's going on. So we have a clock that comes in, we have the enable and the clear, we have the scale factor, which is a 20-bit value, we have a real bound, which is a 20-bit value, and an imaginary bound, which is a 20-bit value. And these are in 8.12 fixed point notation, where the most significant bit is also the sign. Okay, so the reason we have 8.12 notation is because we're using a 128 by 128 screen, so that's 7 bits, and then the most significant bit is the sign. So now what we can do is we can take the value that we're counting out of our counter that says we're on this pixel value and multiply it by some scaling factor to get the real value out, and we do that the same thing with the imaginary value to get with the y value to get the imaginary out. So what you normally do is you set the real bound and the imaginary bound to being negative. Like if you have a square screen, you know, it's the same amount of pixels in the x than it is in the y. You'll set the real and the imaginary bounds to being the same, so you have like a fixed like aspect ratio of what you're viewing. You know, it's not stretched in a weird way. So then when you zoom in, what it does is it just changes it just changes the scale factor that it multiplies. So that zooming is literally just changing a constant that gets multiplied in. So then you need the thing that actually generates those zooming and panning constants. So like in here just gets you the bounds where it'll just calculate the frame for those bounds. Or if you want to then zoom, you have to offset where those bounds are, or scale, or panning, sorry, you want to offset where those bounds are. And zooming, you want to just double your scale, or half your scaling factor, which changes the way it maps. The issue with that is if I leave my real bound and imaginary bound the same when I zoom, then it zooms upon the bottom left. So what I want to do in the future is divide the real bound and the imaginary bound by the shift factor, or the scale factor, which is just literally a shifter. So just have a shifter on the real bound and imaginary bound. It looks at the shift amount, or it looks at the scale amount and tells it how much to shift that number. And then that will then get me zooming about the middle instead, which would look a lot better. So now that you can see that in here the only values that need to be entered are the scale factor, the real bound, and the imaginary bound, which for the default is set to -2, -2, and then 1 over 32. And where do I get those values from? If I'm mapping a 128 pixel screen across the value of magnitude of 4, from -2 to 2 in the x and -2 to -2 in the y, and it's 128 pixels in both the x and the y, I'm mapping 4 across 128. 4 across 128 is 2 over 64, which is 1 over 32. So my scaling factor needs to be 1 over 32. So I take whatever pixel value is, pixel 1, multiply it by 1 over 32, and that's my real whatever value that I add to my real bound. So I have real bound, which is the 0th pixel, and then I add the scale factor times the bound, or times, yeah, just take the scale factor times the pixel and add that to the bound. And that's how I iterate across the screen, and then I increment the y value once I'm done in the x. So like that's how this counter here, the overflow here, comes to the enable pin of that counter there. So that when it overflows, it clocks this one and it just increments that one. And that's how you get a synced counter like that will do that. So now that you see the inputs to this, we look at this now if we open the circuit. The way it works is you have a clock coming in, and that clock is divided down by 1024. It's a 10-bit counter. So what you do is everything starts with the pan factor. So you have a pan factor where you can say more pan or less pan, and you can say, I'm either going to say the max pan factor is 0, 1, or the min pan factor is 0, 1, and the max is 8, 0. And I'm just going to be able to shift that 1-bit value left or right and tell it how much to pan by. So when I press more pan, it's going to increment and tell it to shift left and take the value and add it back to itself. And if I say decrement, it's going to shift right instead. So that's how it's incrementing or decrement, or changing how much I want to pan around. Changing how much I pan around will change what the offsets are for the real bound here and the imaginary bound, because if I have -2 and I move 3 pixels to the right, I want to then have a different value. So the panning here is in terms of pixels. It's not in terms of like an imaginary value. It's in terms of how many pixels you want to pan by. And then that's just done by multiplying it by an offset in my 20-bit fixed point. So now once I have my pan factor, I'm able to then set up my image bounds, which then I just take my pan factor and add that to my image bounds, and I'm good to go. So I say my default is -2 on both the real and the imaginary. I load them into a register and on the default or on the reset, and they go in. And else it'll just either, for the real and imaginary, it'll either add or subtract the shift amount or the scale factor from it. So my scale factor is how much I'm adding and shifting to this, and the real bound first gets initially offset by the pan. And then the scale factor is done similar to the pan, where it's like it's a power of 2, so you're just shifting it left or right. But this one you have a much larger scale factor. You can go from 80000 to 00001, and this just checks so if it's at that bound, it won't let you shift. Like if you're at 00001 and you try to right shift it, it won't shift that 1 out. It always wants you to have a 1 in there, so it always does something. But if something screws up, you just click the clear button and everything's good to go. So this is literally all the logic I needed to set up zoom and pan. So this doesn't have to be changed ever again, and this doesn't have to be changed ever again, because this is beautiful how this is done. So what needs to be changed now is how I do this. In here there's 1, 2, 3, 4, 5 multiplies, but I really only need 3 because these two are redundant. So if I change the order of the things that I do here and use the a squared plus b squared from here to get this greater than 4 and do that at the beginning before things get passed through, I will save 2 multiplications that need to be done per hardware iteration. So I'm hoping that will improve performance as well. And yeah, that then would be everything. And then, you know, you have more hardware iterations, and then you just map more grayscale values. So the issue I was running into is if I have more than, like, you know, 32 iterations, I run out of grayscale values I can map. So because I just have 5 bits of grayscale. So what I'm gonna have to do then is set like one of the blue pixels like always true or something like that, or like set it to the max blue value, and then like iterate the green up and then roll over to the red, and then iterate green up and then increment red again, and you'll have shades of like purple, green, blue generated on top. And I think that might look pretty cool, because I was looking up how to convert HSV to RGB so I could tell it like how to map the Mandelbrot set in terms of hue saturation value, and then it would output the right RGB value to that corresponding. Oh my god, the math required for that is just ridiculous to build in a fixed function ASIC. You just like, it's so much easier to have a microcontroller that you program something that needs that many steps to do something in. So I don't know if it's worth embarking on that project just to have cool colors on my Mandelbrot set when I could just do like some fucking fixed color mapping that doesn't change, and you know, oh no, it's just fixed color mapping, but hell, at least it's a freaking circuit that does what I want, and it's not just something I coded, which I think anybody can do. So anyway, end of rant. Thank you for sticking around to the end of the video. Leave a like, subscribe, whatever, you know, ring the bell, and I'll see you guys next time.